Welcome back, Math 2. Today we're on our 330 notes. Again, I'm sorry that those are not written in there. We're going to just talk about the three main different forms of quadratic equations, how the equations are written, that's what I mean by a form, and looking at the different things that each form gives you and why there's advantages to each one. Now, we're going to mostly work with this stuff in the next unit, Unit 4, but I want you to have an introduction to it and just kind of end our unit of factoring and working with polynomials with what different forms give you and why it was so important that we learned to complete the square and factor and do this and do that, okay? So the first one is called vertex form. This might look familiar. It should look like stuff from Unit 2 when we were learning how to graph all these. And you know what? I'm going to write it in purple. So this would look more like y equals a parentheses x minus h close parentheses squared plus k. All right, now maybe you're like, oh my gosh, that looks nothing like what we did in Unit 2. Yes, it does. Okay, so a quick example might be y equals 2 times x minus 3 squared plus 4. Okay. You had a problem like this where you were asked to describe what each of these numbers does to the graph. So remember, like the 2 makes it stretch, it gets taller or skinnier. Having a minus 3 in the parentheses made it go to the right 3. And having a plus 4 on the outside made the graph go up 4. Okay. So basically what all these letters correspond to over here is that H tells you your horizontal shift. And K tells you a vertical shift. Okay. Now, a lot of times in Unit 2, we just plugged the numbers into a table and then graphed that table. There is a quicker way to do it. I do want you to know that this graph, this form is called vertex form because it gives you the vertex. Remember, the vertex is that point where the parabola turns around. This gives you the vertex in this equation without you having to do any work. And the vertex is the coordinate h comma k. Okay. Now what throws people off is that up here h is negative, but when I pull it out here it's positive. So that means, for example, the vertex of my little example over here would be positive 3 comma 4. And if this was a plus sign in here, like it was plus 3, then it would become negative 3. Okay. And the reason the vertex is so important because that's where everything turns around. Everything is symmetrical across it. There's also this thing in parabolas through the middle of it. So it goes through the vertex and then it's in the exact middle. This is called the axis of symmetry. And it's called that because right here along this, on every side, every point is going to be symmetrical except the vertex because there is no other point that is symmetrical with the vertex. But it means if I have a point over here, it's going to be equal distance to the point over here. Okay. You can also get the axis of symmetry, or the line that represents it, from here. That would be x equals h, whatever your h is. So for mine, my axis of symmetry would be x equals 3. Okay. So this one is really helpful for graphing because you can get your vertex, and if you have your vertex, it's a lot easier to graph. You could just plug points into a table if you know where the middle is supposed to be, and you can pick 2 values on either side. The one that you're probably going to see the most, though, is standard form, and that's where we have y equals ax squared plus bx plus c. Now this one doesn't have as much helpful information, though. This is just the way we write a majority of our quadratic equations. One thing that it does give you is the y-intercept of your graph. Because remember, y-intercepts happen when x equals 0. So if I were to plug 0 into this, I'd have a 0 for the ax squared piece and a 0 for bx, and I'm left with c. So my y-intercept is going to be 0, comma, whatever c is. Okay. And this one is kind of nice because this is fairly simple to factor and get it into factored form, because then factored form tells us a lot more stuff. Okay. So often this is going to be our starting point, and we want to get to either vertex form or factored form from it to get more information about the parabola. And we'll talk about that more in our next notes, like how we actually switch, especially from standard to vertex. But to go from standard to our factored form, we just factor it. And I'll show you an example in a second here. But you can still get the vertex from your standard form. You just have to do a little bit more math, okay? Because again, the vertex is kind of the most important piece to be able to find. Having the y-intercept is also helpful because if you have the vertex and one other point, you can reflect that point across that axis of symmetry, and then you have enough points to make your whole parabola. So the vertex, I can get the x-coordinate by using negative b divided by 2a, and a and b come from up here. Then to get y, I just plug whatever x is back in. Okay, so let's say, for example, I had y equals x squared plus 6x minus 3. Okay. All right, so first off, my y-intercept would be 0, negative 3. And my vertex, I can do negative b, which is 6, so negative 6 over 2 times a, which is 1. And I get negative 6 divided by 2, which is negative 3. If I plug negative 3 back in for x, I'm going to get negative 3 squared plus 6 times negative 3 minus 3. So this will simplify down to positive 9 minus 18 minus 3. So let's see, 9 minus 18 is negative 9, and then I'm getting more negative to negative 12. So my x-coordinate is this negative 3, and my y-coordinate, my vertex, is negative 12. So here's how that's helpful. Okay, so this is my graph. So I know at negative 3, 0, negative 3 is my y-intercept. And I know that at negative 3, negative 12, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. At negative 3, negative 12 is my vertex. Okay. Well, if I have my vertex, I know the vertex is exactly in the middle, so now I can say, okay, I know my y-intercept is 3 spaces away from the middle of my parabola, so I can make an exact point on the other side 3 spaces away. And now I have a parabola. Woo. Okay. All right, let's talk about factored form. Okay. So factored form in general looks like this. Y equals A times x minus R1 x minus R2. Okay. And R1 and R2 stand for roots. And roots is just another name for your x-intercepts. Okay, they're often called roots, x-intercepts. They can be called zeros of the graph. Okay. So you've been working a lot with factoring and getting everything down so that you can solve for x. And that's the point of factored form. Factored form gives you those x-intercepts. And here's another reason it's helpful. Let's say you were given, because you can also find the vertex from factored form fairly simply. Let's say you were given x squared minus 10x plus 24. So this is in standard form. Okay. We're going to change it to factored form by actually factoring it. So I have an x squared, so there'll be no a term out here. It's just going to be x and x. And I need two numbers that multiply to make 24, but add to make negative 10. So they're both going to have to be negative. And I think it's going to be negative 6 and negative 4. Okay. If you were to, so this is what the factored form would look like. Y equals x minus 6 times x minus 4. If I were to solve both of those set equal to 0, I'd get my roots at 6 and 4. Okay. So that means 1, 2, 3, 4, 5, 6. So that means I have an x-intercept at 6 and an x-intercept at 4. These are my intercepts. Okay. Now again, remember, everything is symmetrical around your vertex. So if I have 2 points, my vertex needs to be halfway in between. Well, in between 6 and 4 is 5. So that means my vertex must be somewhere along 5, along this line where x equals 5. Sorry, that didn't quite line up. And here's how that's helpful. If I know that x is supposed to equal 5 to get my vertex, I can plug 5 back into either my standard form or my factored form and solve for the y-coordinate, and then I have my vertex, and then I can make my parabola. So I can plug it into either. If I plug it into my standard form, that wouldn't be so bad. I'd have 5 squared minus 10 times 5 plus 24. If I did it in my factored form, I'd have 5 minus 6 times 5 minus 4. That might be quicker for you, I don't know. So 5 squared would be 25 minus 50 plus 24. This will probably be quicker. So 5 minus 6 is negative 1 times 1. So I'm going to get that y equals negative 1. So that means my vertex, I'm sorry it's got a little messy, is at 5, negative 1. So if that's my vertex and I have my 2 x-intercepts right here, there's my graph. Okay. So your homework is going to focus mostly on these 2 forms, and then we'll talk more about the vertex form tomorrow.